Yeah, good morning, Mundo. Today we will see introductions of restricted goals condition, RB, Unit 4. Yes. What's restricted goals condition? Already you know goals condition. The goals condition, basic fundamental concept for goals condition is there are two layers. One is a hidden layer, another is a layer. But what's the difference between the RB and VM? For VM, all the visible units and hidden units are interconnected, and also adjacent nodes, like the visible nodes, all the visible nodes are connected to each other. This is what the Boltzmann condition. What's restricted Boltzmann condition? The restricted Boltzmann condition, different from the Boltzmann condition, that visible node isn't connected to each other, and the hidden nodes are also not connected with each other. Other than that, are being exactly same as a Boltzmann condition. Then what's the purpose of this Boltzmann condition? RBM is the neural network that belongs to a energy-based model. So, Boltzmann mission, we have a connection between the visible nodes and also connection between the data nodes. So, unwanted energy is wasted in Boltzmann mission. So, while regenerating the data, while connecting the information relationship between data, all those things, while running the model, it consumes more energy than the RNA because of the unwanted use. So let's come to the point. What's RBM? It is a probabilistic unsupervised generative deep learning algorithm. It is a probabilistic unsupervised generative deep machine learning algorithm. RBM objective is to find joint probability distribution that maximize the long likelihood function. And also RBM is undirected and only input layer and hidden layer. Visible nodes are connected to all the hidden nodes. But in RBM, two layers, visible layer and hidden layers, uh, are called as an asymmetric biportrait graph. No interlayer connection exists between the visible nodes. There is no interlayer connection between the hidden nodes. There are connection only between hidden nodes and the visible nodes. The original Boltzmann mission had connection between all the nodes. Since RPM restricts the interlayer connection, so it is called as a restricted Boltzmann mission. So in Boltzmann mission, we have the nodes are interconnected. Even visible nodes are interconnected with other visible nodes. Hidden nodes are interconnected with other hidden nodes. But in restricted Boltzmann mission, the interlayer connection between the visible nodes and the interlayer connection between the hidden nodes not present. So it's a restricted Boltzmann mission because of it consumes less energy while running the body. This is the main purpose. So it is called as a restricted batch. Also, RBM objective is to find the joint problem distribution to maximize the likelihood, log likelihood function. Since RBM are undirected, they don't adjust their weight to gradient descent and track propagation. Yes, the RBM already it's undirected graph. They don't adjust their weights through the gradient descent or a back propagation. They adjust their weight through a process called contrastive divergence. They won't use back propagation technique. Now, RPM, they use only the contrastive divergence. In upcoming classes, we'll see what is contrastive divergence, how the RPM is working. We go deeper into next class. But just understand the structure of RPM. What is BM and what is RPM? Why we go for a Boltzmann machine, then why we go for a restricted Boltzmann machine. These things you must understand before going deeper concept. Yeah. Now, and the structure of this process, the weights of for the visible nodes randomly generated and used to generate hidden nodes. So this is for the restricted Boltzmann. But these hidden nodes then use the same weight to reconstruct the visible nodes. See the process of restricted Boltzmann. At the starting, the weight for the visible nodes are randomly generated to generate a hidden node, Then the generated written nodes use the same way to reconstruct the visible nodes. The weights used to reconstruct the visible node are same throughout the system. Let's see that example. For example, the social media. You are again you take a movie recommendation, particular movie watched by the lakhs of people. All the people are giving their recommendation. So that randomly uh, the weights are generated for each recommendation, and it is generating the pattern hidden nodes like okay pattern. Based on that pattern, again it is reconstructing the visible node. Again, it reconstructing the original data, whether to recommend the movie to other person or not. So this is what the restricted Boltzmann machine doing. Same way, the Boltzmann machine also doing. The only difference is that all the nodes are interconnected. Here, only the visible layer and the hidden layers are interconnected. It consumes less energy. There, it consumes more energy while running the node. Then in RVM, we have a symmetric biquadrate graph where no two units within the same systems are same or connected. In multiple RVM can also be stacked and can be fine-tuned through the process of gradient descent and backpropagation. In normal RVM, they won't use backpropagation or gradient descent, but multiple RVM, they can use backpropagation and gradient descent process for the fine-tuning process. Such a network is called deep belief network. Multiple RVM. Yeah, such a network called deep belief network. Although RVM occasionally used, most people in deep learning community have started replacing their use with GANs and with variational autoencoders. Now the RVM is slowly going out from the deep learning community. Then what's the replacement for RVM? Yeah, GANs, General Advisory Network or variational autoencoders. These two are currently we are using the place of RVM. Okay. I think hope you understood the restricted Boltzmann notion. Now just recall all the points what we understood for the restricted Boltzmann notion. Yeah. Introduction about the restricted Boltzmann machine. The restricted Boltzmann machine, same like a Boltzmann machine, but same like Boltzmann machine, it is having two units, visible unit and hidden unit. The only difference is in the Boltzmann machine, all the nodes are interconnected, even the adjacent nodes are interconnected. Here, only the two layers are connected. Visible units are connected with the hidden units. That's all. Or you can either way, you can say all the hidden nodes are connected to visible nodes. That's all. There is no connection between the visible nodes. There is no connection between the hidden nodes, like a Boltzmann mission. Okay. This is also energy-based model. This is also a probabilistic unsupervised generative deep learning model. The main aspect of the algorithm what was subject to, yeah, find the joint probability distribution and to maximize the log likelihood. Yes. It is undirected two-layer model. Okay. No interconnection exists between the visible nodes, also for hidden nodes. Yes. The original mission, Boltzmann mission, having connection path all the nodes. So RPM, there is no connection between the adjacent nodes. Okay. And the simple RPM, they don't adjust their weights to the gradient descent back propagation. But in multiple RPM, the multiple RPM fine tuning the process with the help of gradient descent and back propagation. Then it is called as a deep belief network. Although RPM occasionally used nowadays, most of the people in the deep learning community they started using GANs and variational RPM. This is the main points we learned for restricted Boltzmann machine. Okay, and also what's the main purpose of main operation of Boltzmann machine? Yes, at the starting stage itself, the Weights are randomly generated for the visible nodes and it is used to generate the hidden nodes. Same way, the generated hidden nodes, the generated weights of the hidden nodes, same weight can be used to reconstruct the visible node, vice versa. Okay, so this is what the restricted Boltzmann mission model. So now you understood what is Boltzmann mission, what is restricted Boltzmann mission. In upcoming classes, we'll see go deeper into the Boltzmann mission, how the Boltzmann mission is working. Same way, how the restricted Boltzmann mission is working. Uh, Energy model we will see, so on and so forth. Okay. Thank you. That's all. Today's class is over. Thank you. Thank you.